What's happening, folks? Geologist Philip Prince talking about oil and gas today. Probably going to be the first of many such videos on this channel, but we're not starting off in Texas or Oklahoma. The scene you see here is on the island of Barbados in the Caribbean. Probably not the first place you associate with oil and gas, but there's a very active onshore oil and gas industry there. And in fact, oil just naturally seeps up out of the ground. Really interesting island, in many ways globally unique, and trying to understand why there is oil and gas in this location requires that you really focus in on the geologic setting of Barbados. Interesting island because it is not particularly associated with any big continental landmass. It has pretty deep water all around it. And in most cases around the world, if small islands are going to be oil and gas productive, you would expect them to be closer than Barbados is to some kind of big continental landmass. That's very much not the case here, and the island itself is pretty small, little over 20 miles in length. And the image I started off with there, I just found that in Google Earth with Street View. It's actually pretty easy to find pump jacks associated with oil wells in Barbados. I went down to the southern end of the island there. And actually, right here on the right side of the screen, you can see these well pads with service roads, classic oil and gas signature and satellite imagery. The one I showed you over there is at the end of the yellow arrow there. And as you zoom in closer and closer, you actually see the shadow of the pump jack there, kind of the donkey head shape. And that's the image we started off with. When you work with geology, you actually spend a lot of time cruising around Google Earth just trying to identify things from that satellite perspective. So that was kind of a fun scavenger hunt there. But these are by no means the only pump jacks in the southern end of Barbados. There's plenty of it going on down there. Why is there oil and gas here? Well, if you think about another part of the world where there's oil and gas sort of off the coast, there's plenty of them, but the Gulf Coast of the US is about as classic as it gets. Uh, this is still associated with the North American continent, and the oil and gas production there can be in fairly deep water, but fundamentally it's connected to the margin of the continent. Down in Barbados, that's less the case. Underneath Barbados, you've got oceanic crust or oceanic lithosphere, and you have oceanic lithosphere in all directions for a pretty good distance. And that is what makes the island so unique. In fact, the existence of a small island there to begin with is sort of interesting. And to start digging deeper into what's going on there geologically, got to think about Barbados relative to its neighbors. So there it is. St. Lucia, St. Vincent and the Grenadines, Grenada are close islands to it. You can see the southern tip of Martinique up there at the top of the screen. All these islands are fairly comparable in their size. They're fairly comparable in their shape. All are very good at producing fast runners, which we have seen well represented in the Paris Olympics thus far this year, and just about any Olympics I can remember. But St. Lucia, St. Vincent, Grenada, they're sort of the same type of thing geologically. Barbados could not be more different from them. And it's that geologic difference that fundamentally is the reason that oil and gas is a thing there. So there's Barbados again. You can see it. It sits out away from those other islands. They, along with their neighbors to the north, actually going all the way up to the little island of Saba, make this kind of crescent shape. We call it an arc, and it's a volcanic arc. All of those islands are volcanic, and you don't have to look terribly hard to see evidence of that. The actual volcanic shapes, older craters are visible in many of them. And on Montserrat here, for example, the volcano is very much active. I remember being a kid and watching this erupt on the evening news. You can see these pyroclastic flows that have come down to the ocean. There's still steam and smoke coming out of the vent there. Now, oil and gas are not a volcanic thing. They're very much, in fact, not a volcanic thing. To produce oil and gas in the Earth's system, you need a thick sequence of sedimentary layers of sedimentary rock, and that's what's underneath Barbados. Now, producing such a thick sequence of sedimentary rock happens all over the world. It can happen for a variety of reasons, but seeing it in association with this volcanic arc with these tiny islands, sort of out in the middle of the ocean, is pretty interesting, and that's what makes Barbados so unique. Tectonic plates are moving together here. The left arrow is on the Caribbean plate. The right arrow is on the South American plate. So it's a zone of convergence, and that South American plate is actually going down underneath the Caribbean plate. When that happens, The Caribbean plate is scraping sediment off the top of the South American plate and piling it up into this huge, thick mass. You might imagine a snowplow going down a street and scraping the snow off, and it piles up against the plow blade. Geologically, we call this an accretionary prism. It's essentially a big underwater mountain range, and Barbados is actually just the very top of that, like the pinnacle of that, sticking up out of the ocean. So, in effect, Barbados is actually a really high mountaintop. You would not get a sense of that if you were standing there, though, because the rest of the mountain range, and when I say the rest, I mean the rest of it is still down underneath the ocean. Kind of an unusual visual, something that definitely needs a diagram. So we're gonna hop out to Microsoft Paint here and sketch it out. Hang on just a minute. Okay, here we are, Microsoft Paint. Going to see if I can do the usual block diagram here and give you a sense of exactly what I'm talking about in terms of this snowplow pile of sedimentary rock, the top of which is sticking up out of the ocean. So we're going to need to have a volcanic island, a much lower island that's going to be Barbados. We'll try to draw our Caribbean plate here first. And the drawing that we're going to do here has to be quite exaggerated just to be able to see everything together. In terms of relative thicknesses, how deep things are in the earth, measurements like that, it's very difficult to scale them accurately and essentially show everything at once in a drawing like this. So there will be a little bit of license taken, but fundamentally, the way everything fits together here is the way you want to think about Barbados's setting on Earth, and ultimately why you can find oil and gas there and why you can't on some of those neighboring islands. So we're going to color in our tectonic plates right there. Really just thinking, I guess, about crust in this case. We talked about crust and lithosphere in other videos. Not going to worry too much about it here. You've got the one coming from the right going down underneath the one from the left. That's going to be sediment there underneath Barbados. And we'll start drawing out actually some boundaries of islands right here. So we'll have a couple islands there. Put another one there. Some of these might be pretty closely spaced, no problem. And then that'll be Barbados. I'm gonna add some structure to this thing, and I'll talk about what these little lines represent momentarily. So at this point, we might be able to start filling in some more colors. Going to have the Earth's mantle as green. I recommend the Mariana Trench video if you want to know why I always draw the mantle green. We use a little bit darker color for our islands here. And now we're going to need some ocean water. Looks like all my lines are touching. This is going pretty well here. Okay, cool. So coming together here, let's get a little bit of detail as if we're able to look down through the water. I don't like that very much. I'm going to have to do that one over. Here we go. Okay. Something like that. All right. Moving right along here. Very good. So these volcanic islands are themselves going to be mountains, that are tall enough that they actually stick up out of the ocean. Barbados itself has pretty steep sides, but it, as we have said, is a mountain for a different reason. Have our oceanic trench down here. That's kind of deep spot. We're going to have all these kind of lines and wrinkles here going along that big pile of sediment. Okay, last touch here. We're going to need something to erupt out of those volcanoes. That's going to be coming out of the Earth's mantle here above that sinking slab. It releases carbon dioxide, particularly water. When it gets down there really deep, starts to heat up. So that slab itself doesn't melt. It's the mantle rocks above it. That's what goes up and comes up out of the volcanoes there. Now, Barbados, again, which is this one, has nothing to do with volcanic processes. It, again, is basically a snowplow pile of that brown sediment layer that sits on top of the oceanic plate. Now, out where I just drew that arrow, that sediment layer is pretty thin. Now here, where it's been piled up against that snowplow blade, if you will, is really, really thick. And down there at the bottom of it, temperature and pressure are actually high enough to start turning organic material in those sediments into oil and gas. And if we, in fact, zoom in here just a little bit, drawing still looks okay right there. Kind of down in here is where that oil and gas is going to be forming, and it just makes its way upwards because it's low density. Now, the lines I've drawn there in that brown snowplow pile represent geologic faults and internal structures. As that thin sediment layer gets scraped off, it's getting kind of broken up and stacked up on top of itself. That broken and structured rock produces, among other things, what are called traps that hold the oil down at depth. But if they break correctly, it actually allows it to escape up to the surface. And that's why you see it bubbling up on the island. So Barbados is a very active place. And again, you'd want to think about it like a growing mountain range. Down inside the guts of that mountain range is where the oil and gas is forming. And the depth illustrated here is going to be 4 to 7 kilometers. So it's going to be 2.5 miles to a little bit over 4 miles, maybe even deeper than that, maybe a little bit shallower. It all depends on how quickly temperature increases with depth. One way or another, it's miles below the surface. Out here, you can't do oil and gas. The sediment burial isn't thick enough. Where the pile is really thick, though, it's very much good to go over there, right? So interesting way to think about what's going on down underneath you. Interesting way to think about where those materials come from, but you can actually do better than just drawing that. And let me move my window here. We'll zoom back out. You can actually make one of those snowplow piles as a physical model. And if you want to think about visualizing kind of that snowplow idea, you would have this be the snowplow blade, the snowplow itself. We'll make it kind of like a bulldozer or something, would be over here, something like this. Okay. We'll give it some tracks down underneath it. This is commonly how a geologic system like this is actually diagrammed in textbooks and things like that. So that's the idea of that overriding plate scraping the material away. Producing that as a real model is something you can absolutely do, and I'll show you what that looks like right now. All you need is some kind of a moving base plate. You sprinkle layers of dry sand on top of it, and this is a real thing that is used at the highest levels of geologic study to try to estimate or understand what kind of structures can form from Earth's rocks. Build up enough of these sand layers, add a few colors in there. The white layers are actually a little bit different kind of sand than the other colors. So you get some geologic variety simulated by this. The colors give you a nice pattern, and then you start moving this thing, and it's going to scrape those layers off against that geologic snowplow blade there. And it makes this really cool pattern. It's kind of mesmerizing to watch. I don't know. This is like the geologist's little Zen garden that you rake the sand in or something like that. But that pattern that you see developing, the wrinkles right there, that is a 1/1,000,000th scale Barbados accretionary prism. Depositing the layers and moving them that way to make a thicker pile, that's absolutely what's happening in nature in the real system. If you cut that model open, you see something really, really interesting inside. Incredible pattern there, how those layers have stacked up on top of one another. That's the idea of the little lines there in the Microsoft Paint sketch in the brown accretionary prism pile. They represent thrust faults along which that originally thin layer sequence gets stacked up on top of itself. Really neat pattern. You can change the layers of sand around and get a huge variety of patterns in this way. That would be sea level, and that would be like the oil and gas forming at depth where the material has been buried deep enough because that pile has gotten so much taller and thicker. Oil and gas migrate upwards as far as they're able to. And of course, if you're there on land in Barbados where things are going right, you can actually see it seeping up out of the ground, as it probably does on the seafloor in some locations. So very interesting visual, but That's what you want to be thinking about when you're looking at Barbados, and there's miles of rock that have piled up because of that movement underneath the island. Now, what would it really look like? Something like that. It's incredibly long and wide and thin, like so many geologic features related to tectonic movement. But sure enough, the thickness is more than enough underneath the island of Barbados there to produce the oil and gas. Really cool details that you can see when you look at this thing in Google Earth. You can see the wrinkles down there. If you think back to what that model looked like when it was moving, kind of looks like it. It does so for good reason. It's forming in essentially the same way. The tops of those wrinkles are each about 3 miles or 5 kilometers across. So kind of interesting, gives you a sense of the physical scale here. And if you look at a basic conceptual structure of what one of those wrinkles or folds might look like, how wide it is gives you some sense of how thick that folding layer might be. You can use a little bit of trigonometry there if you know the angle at which the layers are breaking, or can estimate it to give a sense of how thick the folding layer sequence is. And in this case, around Barbados, it would be kilometers thick. It would be a couple miles thick or more. Model shows basically the same thing. Those wrinkles that you see on the seabed are just like the top of the wrinkles there that we were able to produce, again, at that 1/1 million scale. So kind of a cool way to think about what's going on inside the Earth. So Barbados is unique globally because it's one of few places that one of these accretionary prisms with oceanic crust underneath it has gotten big enough and thick enough to actually poke up out of the water. It's arguably the only one like it that produces oil and gas as well. There's a circumstance in Indonesia that is similar, but it has more association with more like a continental type of crust. So Barbados is very much one of a kind, and the story gets even more interesting when you think about where the sediment came from that's being plowed up against the edge of the Caribbean plate. It came from South America, the Orinoco River in particular. Not quite an Amazon, but it's a big river. It moves huge amounts of sediment, and the ancestral, if you want to call it that, Orinoco River, been doing that for a long time. So huge amounts of sediment have piled up there on top of that South American plate, and that's what the Caribbean plate is scraping up there. Now, coming along with that sediment from the land actually is some organic material. Oil and gas don't form from dinosaur bones, animals, whatever, common misconception. They form from effectively microscopic organic debris in water that settles down at the bottom. And that debris has to have been related to photosynthesis. So it can actually be kind of pulverized plant remains. In many cases, it's dead critters from the water column, but microscopic ones, phytoplankton, algae, things like that. Photosynthesis is key in terms of an organic source for oil and gas. You can get some from the river, you can get some from the ocean as well, and that gets buried down there, caught up, pulled down into that big growing pile, and that's where it turns into the oil and gas. So kind of a cool process, and it's also neat to consider that Barbados is essentially made of material that got washed in off South America. Big geologic debate with oil and gas in Barbados is actually whether most of the oil and gas is coming from stuff that South America washed in, or if it's coming from material that developed actually in the seawater. And if you just can't take any more Olympics, go Google Barbados kerogen type, and you will find all kinds of discussions about where that stuff came from. So when geologists are working with a system like that, they want to know what sediment layers are producing the oil and gas, because that would allow you to go elsewhere in this region and maybe find some of those resources in other places, right? So if you step back again, there's the Orinoco. You even got the Amazon down there, which of course is delivering insane amounts of sediment to ocean basins. And some of the finer material associated with that can actually make its way up there and deposit on the South American plate, and has been caught up in this process as well. So Barbados is the top of this big underwater mountain range. The mountain range is made entirely of this scraped up sediment that has just enough organic material and the right kind of organic material to make oil and gas. The pile of that sediment's gotten big enough to start generating it. And because of the internal structure of that thing, it's actually broken up enough that some of it seeps out at the surface and some of it stays trapped underground, and you can get it out of there economically. So kind of a cool intersection of circumstances that requires you to think about plate motion, all these funny little structures that you can actually see with Google Earth and what they say about plate motion and how that ultimately defines like this one island with this really kind of unique economic asset to it that sets it apart from its neighbors. Now, it looks like the neighbors in terms of geography, shape, size, whatever, but it's the geology that is totally different. So really neat spot on planet Earth, and one that's worth a look like so many others with Google Earth. Hope you enjoyed this one. Probably gonna be back to the Appalachians next time. This is a little bit of a geology vacation, but hope you'll check that one out.